Welcome to week 9 of Paul's 2044. Today we're talking about probability and hypothesis testing. Specifically, I want to talk to you about why we use the statistics we're using in the course, why we should care about probabilities and probability theory in general, why we should test hypotheses as a way to link the causal theories that we have to data about the real world. And finally, why should we run a regression? Multiple regression is the destination for the types of methods that we're going to be talking about in this class. And today I wanted to give you a bit more detail about that method, as well as a number of other methods to see the underlying similarities and the assumptions that these different hypothesis tests have. So let's go ahead and get started. So when we talk about statistics, it's hard to not think about Mark Twain's dictum, there's lies, damn lies, and statistics. He attributed it to a British Prime Minister, Benjamin Disraeli. No evidence of that Prime Minister actually saying that has been found. But another quote by Andreas Daniels, it's easy to lie with statistics, but it's hard to tell the truth without them. Over the course of the term, we've talked about the various different ways that we can describe the world, our focus on telling stories, explaining why particular things happen, and a number of different methods to evaluate those causal stories that we tell, whether using qualitative approaches or quantitative. The last couple of weeks, we've talked about a number of different quantitative, descriptive, and inferential statistical methods. And I think this quote connects to a number of different issues that we've raised in this class, that it's easy to make mistakes, to lie is another way to put it, on purpose or whether by accident, but in really trying to tap into the underlying truth about the political, economic, or social issues that we care about. The statistics that we're going to be talking about today in lecture and in tutorial are fundamental methods used in a huge number of industries in order to tap into underlying processes and help us build knowledge about how and why the world works the way that it does. And in all of these different methods and approaches that we've talked about in this course, I think it's clear, and I've tried to stress, that it involves making a number of different choices. What research question do I have? How can I move from a general interest in a specific topic to ask a concrete research question? There are infinite number of questions that we can ask about the world. How do we choose one that really can help us understand something that matters, that can link into what previous people have done before, and can help put us in a direction to put forward some interesting theories and empirical tests? What arguments do I want to make? It's hard as students of the political science to truly decide what we believe and how we might evaluate previous theories and what we might use from our own experience and our own reading of current and previous events about what arguments we really want to make about a specific outcome. And that is really truly one of the most important ways of trying to switch from being a consumer of research to being a producer, is figuring out what arguments do we find credible and what we want to figure out in the future. Third question is, what are the observable implications of my argument? That also involves a lot of different choices about how we link theory to observable implications in the hypotheses that we're going to test. How can we frame those observable implications in which they're falsifiable? There's a clear null hypothesis about no relations between the outcome and the cause that we want to focus on. So there's a lot of different ways that we can think of observable implications, the level of analysis that we pitch the observable implications. All this involves a lot of different choices about what we're really trying to say and what evidence is out there that we want to try to link to, because often we don't want to let the perfect be the enemy of the good, and so we have to try to use what data there are out there and to tweak or revise our arguments and observable implications in light of the evidence that exists out there. The main focus today that I want to talk about the inevitable choices that we make when using a descriptive and inferential statistics is trying to decide which ones I want to use. Often there might be a choice that's the most popular, the most frequently used in literature. However, given the nature of our theory or the types of evidence that we want to use, potentially there are other descriptive or inferential statistics that might be appropriate. So there's always a choice. Which ones are we familiar with? Which ones that might match the assumptions of our data? These are fundamentally important choices. We're starting to be aware of the number of different statistics that are out there. And at the end of this course, hopefully I'll give you a roadmap to understanding our underlying theory, underlying nature of the data that we're using to help us make informed choices after you leave the course. And a lot of these choices might not necessarily be that complicated. They could be as basic as talking about the difference between the mean and the median value of a specific outcome or variable that we want to try to describe. I mean, they're both pretty easy to calculate. The mean value is basically the sum of all the different observations over the number of observations. The median is just ordering the variable from smallest to largest and choosing the middle value. It's harder to decide which one gives a more accurate measure of what the substantive middle means in a given situation. And I think there's a famous example of if you're looking at average income of a number of people having a drink at a bar, and you might have a good idea about what the median and mean value is. But what happens when Elon Musk saunters in with a bottle of absinthe and proceeds to join the other drinkers at the bar? How is the difference between the mean and the median income of those people at the bar changing when the richest man in the world comes in and sits with them? The mean value is going to change dramatically, because when you have an income of billions of dollars a year or cumulative wealth of hundreds of billions of dollars, that's going to drag the mean dramatically to the right. However, the median won't really change because median values are not sensitive to outliers. So they might change just by the sheer number of people that are lined up in that list. But the median value will be the one, if you're really looking at what the central tendency is for income of those people at the bar, then you might want to lean towards the median, because the mean is more sensitive to those outliers and can lead to skews. This is a fundamental choice when trying to talk about summary statistics. Often mean values are used. However, learning a bit about your data, how they're distributed, and how important outliers might be to dragging the mean away from the median is something that's worth thinking about. It involves fundamental choices informed by analysis of your data. Another way of looking at these kind of household or individual incomes connects to these statistics I got from the Australian Bureau of Statistics of weekly household income within Australia. You see the difference in the financial year of 2019 to 2020. The mean income was $2,329, while the median value was $1,786. So you see quite a substantial, almost $600 difference per week between the mean and median value. And of course, that's because those wealthier individuals within Australia are pulling up the mean value, while the median value isn't as affected by that. Another more personal example of the importance of understanding the difference between these two most basic types of descriptive statistics is this article by Stephen Jay Gould, an evolutionary biologist at Harvard. He died 2 decades ago now, but he was incredibly influential in paleontology and evolutionary biology. He was the one that came up with the idea of punctuated equilibria in evolution, that there are these areas of time in which evolution stays pretty constant, animals don't change that much, and then there's a punctuated equilibrium, and all of a sudden you see dramatic change. The lesser known, but I think relevant to the topic for today, is this article, The Median Isn't the Message. And he wrote this a couple of years after that he was diagnosed with mesothelioma, I think I'm pronouncing that correctly, a form of stomach cancer in which the average life expectancy is 8 months. He ended up dying of a different type of cancer 2 decades later. And what he did after he was diagnosed with this form of cancer, he being an academic, of course, is he wanted to read the literature, looked at the statistics of survival rates of people with stage 4 form of this cancer. And he initially was quite shocked that the mean life expectancy was only 8 months. And or the median value was the mean value was 8 months, because there was basically a difference within the data between people who had it and died relatively quickly and a long tail of people that ended up living years and years later. So the median was around 8 months, but there was a significant number of people, though not 50%, that had a much larger life expectancy. And so this article highlighted the point in which you have outliers might be the ones that you want to aim towards, whether it's Elon Musk or surviving a long time with cancer. And that these kind of basic statistics, you might reach life and death conclusions about the world depending on what kind of statistics you use and how much you actually learn about the values that different people can have with this one particular variable. Another choice that we can make when using statistics is using raw numbers versus percentages. And the raw numbers might be a particular interest if it's potentially the number of dollars that you or Elon Musk has, or the amount of calories that we're taking in a particular day. Otherwise, when you're trying to do comparisons, we talked last week about the importance of comparing groups. That is when you want to try to put values on some kind of common scale, and percentages are a distribution of one particular variable, which, like here, how many voters chose labor in 2022. That would give you a raw number versus what percentage of voters chose labor. And that percentage is just the labor vote over the total vote of labor and all other options. With percentages, you can break the values up into groups of individual percentages or percentiles. But it helps kind of explain how those outliers might be at an incredibly high percentile when you really want to look at between 25 and 75% or such. But percentages can help put things on a common scale and make it easier to kind of break things up in a meaningful way. Connecting it back to household income and net worth, you see how income and wealth are broken up into 5 different quintiles, the 0 to 20%, 20 to 40, 40 to 60, 60 to 80, 80 to 100%. And you see how the top quintile, the top 20% of people in the Australian population really skew at a higher income and higher wealth that pulls that mean away from the median value. So again, when you use percentages, it helps put things in a different scale. However, you also need to potentially think about the raw numbers depending on what outcome you're interested in using for example, election violent events. We use just absolute numbers often for the number of events in an election cycle. If you would change it into percentile, you could have, okay, here's a total number of events that are reported in the newspaper related to the election. What percent would be violent? Potentially that could get at how large or complicated an election cycle is and give you those events potential meaning in the larger scale of things. Another way of trying to control raw values by other values that potentially have more meaning is the difference between those income and wealth values would matter whether you're looking at the true value or inflation adjusted values. So either the nominal value, which is just the dollar amount, or the real value, controlling for inflation to one benchmark year. So if you look at time here, you see inflation has varied pretty stably between 0 and 1% for a number of years. Then the economic crisis hit and the C-19 pandemic in 2020, and you see quite dramatic inflation over the last 6 months or a year. And so when you try to understand the meaning of those inflation, those income or wealth figures in the previous graph, potentially you might also want to think about not just percentiles, but also transforming those raw values into something that has more meaning, like values that are controlled for the prices that we're all paying, whether at the gas pump or in the supermarket, because that might have more meaning and make it more comparable across time for the particular factor that we're actually looking at. Another fundamental choice that we need to make when using or analyzing statistics is whether we want to use those same raw values or combine multiple factors related to an outcome that we might care about into a larger index. And for one of the assigned readings, the Hibbs 1978 article, he actually came up at an incredibly early time period, a way to try to collapse several characteristics of industrial strikes into one measure that he calls strike volume, that looks at frequency of strikes, the duration of the strikes, and the size, the number of people that are involved. So 3 really interesting and distinct characteristics of that latent strike volume or importance within a country, and he comes up with this index. And you see a whole bunch of different indices in a number of different topics that we've looked at in the course. Corruption is an index coming from a number of different raw values. The human development would be another example of those. The Human Development Index here has these background, latent, theoretical dimensions: a long and healthy life, knowledge about the world, and a decent standard of living. Then comes up with a number of different observable indicators: life expectancy at birth, mean years of schooling, etc., and then combines them into one overall Human Development Index. And this has an advantage of simplifying complex phenomena like level of development, human development, into an easy to understand, maybe not easy to understand, but easy to summarize and compare different values for different countries in one particular measure. So when we look at and we ask questions for your own research, do you want to choose one specific element, so life expectancy at birth, and make an argument about why that captures the part of human development that you really care about? Or do you want to be more holistic and have a general kind of like varieties of democracy index, a more general concept that has a number of different characteristics merged into one overall score? This is one of those fundamental choices that we make. There isn't any right or wrong answer. It depends on what questions you have and the arguments that you're trying to make. And then the one final kind of question and decision that we all need to try to make when we're using these kind of statistics is what unit of analysis is relevant. We talk about these complex latent phenomena that are hard to measure. Another one is globalization. And you can ask a research question: is globalization making income inequality better or worse over time? So this is a research question, a general outcome that you're trying to explain. However, you can reach completely orthogonal or different conclusions depending on what unit of analysis or level of analysis that you focus on. So if you're interested at the country level, then globalization, the evidence suggests that globalization is contributing towards countries becoming more unequal. Rich countries are getting richer at a faster rate than poor countries. However, if you look at it at the individual level, the total raw number of people and their income and that income inequality between people, then income inequality is actually reducing. People are becoming more equal as the number of the world's poor is declining. There are rich and more poor people, but the sheer number of people that are being raised up from the bottom leads to an overall decrease in measures of income inequality. So the questions you ask, the levels of analysis, the type of data that you use, and the type of descriptive statistics analyzing the data can lead you in a whole bunch of different directions. And so that's why it is important when we're trying to make conclusions that we try to connect back to what we've seen earlier in the term, those 4 hurdles of causality. At a theoretical point, is there a credible mechanism connecting X and Y at a particular level or a particular X and Y that you choose to use? Can we rule out the Y and X having an endogenous relationship, that maybe it's the Y leading to the X? These are 2 more theoretical questions. Is there covariation between X and Y? We've seen Pearson's correlation coefficient several weeks ago that talk about whether the correlation coefficient is higher or lower, and is it statistically significant or not. And we're going to look at other ways of trying to estimate covariation through regression. And the last one is, have we controlled for potential spuriousness? That we're going to get to in a bit later on, in which we'll include other potential factors that could shape income inequality, for example, or human development. So these are the 4 hurdles that we always need to try to think of when we're trying to establish causality in our data analysis and in our theories. And for the rest of today, I really want to focus on a couple of fundamental and general questions. First, how can we try not to lie to ourselves and to others with the statistical analyses that we use? How we can try to minimize the chance that we're making a mistake or we're misleading ourselves and others when we reach our conclusions. How do basic probabilities underlie most political science research? When we're talking about some of the basic tenets of probability theory and how we use it to create a lot of the research that we've read so far in this course, and that you will produce in this course or in other courses. And the last question is, can we understand several more types of hypothesis testing? So all these different methods are geared towards trying to decide, is there any relationship between two variables or 2 different samples of the same variable, or is there actually, can we reject the null that there's no relationship and conclude that there is a statistically significant relationship? So we're going to look at a couple of different ways, looking at tabular data and regression. So those are our main questions that we're going to be focusing on today. And so with that, some initial takeaways from this section. There's no one right way to conduct qualitative research. Similar to our discussion of qualitative research earlier, involves choices and understanding the phenomena we're trying to explain and the implications of the theories that we put forward. We have a number of different tools at our disposal, and we want to try to choose the ones that we understand and that we can apply in ways that we can understand. We don't want to consciously or unconsciously lie with the data, because we have to thoroughly understand our data how they're distributed, their means, medians, standard deviations, etc. The methods that we're using, we want to have a fundamental understanding of these basic methods, because it's easy to kind of jump to using them, but if we use them without understanding what the assumptions are, what actually goes into the different formulas, then you can make mistakes or to create conclusions that don't make sense to you or to others that you read it, because you're violating one of the basic assumptions of them, which is the second thing that's important to understand. And the third is how to interpret the results. What does this number mean that this method is generating? How do we understand what it is, and how can we connect it to what we really care about, is that hypothesis test? Is there no evidence of a significant relationship, or is there one, and how large that is, the substantive significance, which we're going to get to a bit later on next week. So with that, let's start with the next section, talking about the basics and why we should care about probabilities and probability theories.